Assalamu alaikum. Good evening for everybody, and welcome to this presentation about gas processing and conditioning. It's my pleasure to be here with you to share my knowledge with you and get some information and knowledge from you also about this topic. At the beginning, I would like to introduce myself to you. My name is Jamal Amir. I'm operation engineer. I worked for different international oil companies. I have around 25 years of experience as operation engineer and freelance instructor. Today, I will present this webinar as an introduction for the next course of which will be held on 26th of February to discuss more details about this course. Okay. At the beginning, we'll start about the course outline. This outline will not cover all this outline will not cover here, will not be covered here during our presentation, but it will be covered in the next coming course on 26th of February. So here I'm showing here all the outlines of the course in this slide and the second slide. Okay, so first of all, we'll talk about the introduction of to natural gas processing, physical property of natural gas production and impurity in the gas, gas liquid separation system, separator type, and separator sizing. Common variables such as pressure, temperature, and flow level instrumentation, control measurement of the natural gas. Hydrate formation condition and hydrate prevention and mitigation methods. Dehydration of natural gas, NGL recovery and removal of heavy hydrocarbon. Glycol dehydration unit, process description of TIG, triethylene glycol. This type of glycol is liquid. We have different type of treatment, which is a solid adsorption, while we are using here in this method liquid absorption methods. The factor affect that triethylene glycol dehydration and performance. Troubleshooting, we'll talk about troubleshooting of the unit and how we solve this problem, which we could face during operation. The nature of process problem affecting performance of this treatment. Also, we'll talk in details about sweetening systems, the removal of acid gases, H2S and CO2 sweetening systems. We'll talk about different methods. There are many methods to remove acid gas of the natural gas. So we'll talk about it in details in the course. And we'll cover also different problem and troubleshooting of this facility during operation. Also, it's very important to talk about gas compressor because we cannot facilitate or export gas to distribution network to distributions without gas compressor. So we'll talk about centrifugal gas compressor operation and troubleshooting. Is it clear? So what is the importance of natural gas and what is the natural gas? And why all or most countries in the world paying a lot of monies to try to find some reserve of natural gas or energy source? So as you know, natural gas is a clean burning source of energy that is used for heating, cooling, and electricity in generating. Raw natural gas extracted from well always requires conditioning and processing before transportation to the end user. Gas processing and conditioning is a stepwise industrial process to purify raw natural gas from contaminants such as water, hydrogen sulfide, carbon dioxide, and any higher molecular weight hydrocarbons. So, the natural gas, what is the natural gas? Uh, natural gas is a gas consisting primarily of methane, CH4, and it is found underground in reservoir, mm, and we can produce this gas by drilling a well to this reservoir and complete the well according to the purpose of production. So we can produce these gases through the wellhead to the stations, to the gas plant, and for further treatment. So natural gas processing include all processes which are used to purify raw natural gas. The processed natural gas is uh, used as fuel by residential, commercial, and industrial consumer. So after treating, after treatment of the natural gas, the result of this treated gas is distributed for usage in different area of the life, either for heating or gas or power generation, electricity generation, for general usage in the life. So as I said, the raw natural gas, in addition to the methane, it's contain also uh, varying amount of different compounds and different gases. So we have heavier gases, hydrocarbon, methane, propane, normal butane, and isobutane, pentane, and higher molecular weight hydrocarbons. So when we process and purify when these gases or this gas which contain high uh, molecular weights components, when we process these products are produced as byproduct. So byproduct of the natural gas and form as a natural gas liquid, NGL. This NGL have another treatment during by fractionation towers to fractionation for further treatment by fractionation towers. This fractionation tower demethanizer, deethanizer, deprotonizer. Also, natural gas contain acid gas, CO2 and H2S, and mercaptan such as methane, nol fuel, and ethane fuel. Other gases, we have nitrogen and helium. Also, we have water as in form of either liquid or vapor, like water vapor. Liquid hydrocarbon as condensate mercury. This is as typical natural gas composition or component. We have here as an before treatment. So we have this composition of natural gas. Methane, as we see, between 70 to 98, methane, propane. Here also we have different compositions of different areas or different gas samples from different locations. We got in table A. And we see the compositions of natural gas. We see here the C1, as we said, methane, almost between 70 to 80%. or 65. So methane is the most percentage, or the majority percentage of the raw natural gas. We have C2, C3, C4, C5, and some H2S and other gases. Here, as we see here, the importance of natural gas as energy source. It form around 25. It's form around 24.5 of the total energy of the world. So this percentage is not small, and it is worth to invest money and put capital money to find and search for more reserves of gas. Gas reservoir could be dry gas or could be wet gas. Okay, and the gas which we used here could be either coming from pure gas reservoir, as we said, it could be dry gas reservoir, or wet gas reservoir, which is some condensate is produced with this gas. This is we call it non associated gas. While the associated gas is produced from crude oil. This crude oil is containing, or some gases are dissolved in the crude oil, and this gas forms a source of energy to produce the oil from the reservoir to the station. So we call this gas is associated gas to the crude oil. So we have two sources of gas, either from crude oil or from dry gas reservoir. Here we see in this chart we see the country which is higher producer of the gas. We see here Russia, Iran, Qatar, and all these countries have proven natural gas reserves by country. So we have this total proven reserves estimated to be around 6,040 trillion cubic feet. It's a huge number. So what is the sources of natural gas? Just I talked about it. So we have non-associated gas and we have associated gas. Non-associated gas are produced from dry gas reservoir or wet gas reservoir. Dry gas is just dry gas we receive, while wet gas we receive gas with some condensate, and we have to separate this condensate and any vapor water from this gas during the treatment. Associated gas, this gas is produced with the oil, and as I told, it is a source of energy that produce or move the oil from reservoir to the stations through wellhead and pipeline. Also, we have the third source of gas is, we call it coil bed gas. What is the coil bed gas? Here, raw natural gas can come from methane deposit in the pores of coal seams, such gas is referred as coil bed gas. And also, it is called sweet gas because it is relatively free of hydrocarbon sulfide. As we see in this diagram or this sketch or photo, we have here reservoir, we have oil reservoir, we have gas reservoir, and we have here gas reservoir. So this is dry gas, here dry gas, while here we have associated gas, which is produced by crude oil. And this gas will be sent for, of course, for initial treatment, then further treatment in the gas plant, and after that for exporting. We have here pipeline specification, pipeline gas specification. As we said previously here in this table, this is wet gas, raw natural gas. It is contain a lot of uh, compounds that could create a lot of problem during transportation of the gas. So we have to remove this and remove this contaminant or impurities of the gas before exporting it to the consumers. So as we see here is table one. So we compare this table one by table two. So table two, we see here the final export of final the analysis of final point of export side from straddle point plant mode. We have here around 89.6. So after final treatment, so we get natural gas around 89 or sometimes 99% methane, C1. And we see C2, C3 very little amount, while the acidic gases H2S and CO2 are removed during sweetening process. Because why we have to remove this is gas is sold that is sold for commercial usage is quite different from in composition in the gas that given in table A. So typical composition of the gas is sold directly as industrial fuel. So this is we call it as industrial fuel for usage in table B, and which is as or typical pipeline gas compositions. Here, one point also, this gas, which is sold, is not specified now by chemical composition, but it's specified by a series of specific properties that must be met after treatment. And this condition are set by the client who wants to buy our gas. So he has to get his gas with certain conditions, and this condition we have to achieve it during our gas treatment facility. Pipeline gas specification, as we said, all the acid gas compound H2S and CO2 must be removed. All the free liquid, both hydrocarbon and water, have to be removed. General metric specification are shown here in the following table. So this is the specification that purchaser, our client, they ask to be achieved. So we have heating value, BTU, British thermal unit, and hydrocarbon dew point. This is very important factor also. Water content, H2S content, and total sulfur content. Okay. We have here some special specification: hydrocarbon dew point, water content, total sulfur. Also nitrogen content, hydrogen sulfide. Hydrogen this compound is very important. We have to take care during our treatment. So because it's most of propane having during the or comes from acid gas. So this compound is cause of sourness in the natural gas. So when we have the concentration of H2S more than 4 ppm volume per volume of the gas, so we call that gas is sour gas. So it's one of the most dangerous industrial gases. H2S has to be removed from the raw gases by sweetening process, and H2S content of the gas is reduced to less than 4 ppm depending on the pipeline the gas is being sold to. Also, other specification of gas and specifications that we have to achieve are removed: carbon dioxide, also carbonyl sulfide. Also, we have this condition: delivery temperature and delivery pressure. All these conditions we have to achieve to buyer. To the person who, to the client who is buying our gas. So requirement for gas treatment, why we need to do process treatment for the gas or for the natural gas or for the raw gas to add value of the gas and improve its heating value, to make it dry because water cause corrosion and hydrate, to meet customer specifications, heating value, and H2S content, to manage toxicity and corrosion concern about H2S, CO2 corrosion toxic, to achieve the delivery condition, as we said, pressure and temperature. It's very important to reduce the water content in the gas stream to below limit uh, from 6 to 7 pounds per million standard cubic feet. So gas processing and conditioning, what we have here, conditioning, what activity would happen here in the conditioning, field separation, gas sweetening, and gas dehydration. So all this activity or process treatment should be done for raw gas to make it as per required specification for sealing. And processing, we have extract main component into methane, ethane, propane, LPG. So here, general steps, what are them? These steps are in general. Okay, some gases maybe doesn't require all these steps. Some gas require all these steps in gas treatment. So removal of free water. First step is removal of the free water, liquid water and natural gas condensate. Because natural raw gas, when gas flow from separator to the gas plant area or gas plant area, that gas is wet. It's coming with the separator, holding some condensate, holding some vapor water. So we have to remove all this one before introduce this gas to gas compressor first or for treatment. Removal of acidic gases, hydrogen sulfide and carbon dioxide by sweetening process, removal of water vapor by dehydration process, either by absorption or adsorption. As we know, we have, because dehydration and sweetening, this can be by liquid or by liquid through absorption process or adsorption process through desiccant. So we have many type of desiccants. So to remove the water and make the gas or dry or remove H2S from the gas. Mercury removal. Some gas doesn't have mercury, so doesn't require this process. Nitrogen removal by adsorption process using activated carbon or molecular sieves as absorbent. Recover the natural gas NGL. This is also one process of gas treatment. Okay. This recover natural gas liquids NGL. This, as I told before, it is as byproduct of natural gas. So C1 is exported, while these are have further treatment and through fractionation system. This is a common this sketch or summarize what I have said. So we have gas well or raw gas. So we have condensate and water removal. Okay. And so condensate to send to refinery, to oil refinery, or can send to the oil export system. So can mix it with the export oil after stabilization to improve the API, to improve of the exported oil. While here raw gas is sent first to unit, we call it sweetening unit, acid gas removal. So we have all these methods can be used to remove acid gases. Acid gas also can be if we have high concentration, and it can be sulfur unit to get sulfur element sulfur, and gas or gas could be sent to incinerator. Here is a gas, raw gas after sweetening process. We send it to dehydration system. Or as we said, with dehydration, we have two type: glycol unit or pressure uh, swing adsorption. Mhm. Then we have mercury removal and nitrogen removal by this uh, by this methods of treatment. Then we have NGL recovery, turbo expander, and de-ethanizer absorption in the older plants. Then we have fractionation trains, de-ethanizer, debotanizer, and we have here, as we said here, the gas, the red color, the same gas for pipeline. Here we have C1 is sent from here, from this point NGL recovery, while we have as byproduct of natural gas treatment, we have here NGL, which will send to fractionation system. Here also we have summary, simple summary: gas in conditioning and NGL extraction. So gas will be here, gas to client. Here, stabilization can use it as fuel, and some gases final treatment. So we have dehydration here, CO2 removal, H2S removal, condensation absorption and adsorption. We have de-ethanizer here by stabilization, de-ethanizer, deprobotanizer, final treatment, CO2 removal, sweetening. Hydrate. Well, here the most common problem which is associated with the gas treatment is hydrate. What is this hydrate and how is it formed? So hydrate, all gases have capacity to hold water in the vapor state. So this is true for the following: air, natural gas, nitrogen, carbon dioxide, hydrogen sulfide, and hydrogen. So all gases have the capacity to hold water in the vapor state. Vapor state. The capacity to hold water is a function of what? Gas composition itself, pressure, temperature of the gas. So these main factors which affect the gas capacity to hold more water or less water or water vapor in the gas. So, and solubility of water in the gas increase by increasing temperature and decrease by increasing pressure. In the water containing natural gas, the presence of water vapor in natural gas has very little effect on the hydrocarbon phase behavior, but involve many problems. What are these problems? We'll see. Liquid water and natural gas can form solid hydrate. So the main purpose of water removal is to prevent the formation of hydrate. This hydrate is ice-like, which is could plug equipment or pipeline. Natural gas containing CO2 and H2S acid gas in the presence of free water can cause corrosion. They will cause acidic and could cause corrosion in the facility. Water vapor in the natural gas may condense in pipeline, which potentially causes slugging and flow conditions. If the water, when we export the gas and that gas still the dew point is not as per requirement, and if the temperature of that gas is or fall down during the way below the point dew point, that some water will condense, and this water will cause some kind of slugging flow condition, and which will affect the downstream facility. Water vapor increases the volume, which lead to reduced line capacity. Also, when the water condensed in the pipeline, this will affect the capacity of the flow line and decrease the heating value of the natural gas. So as we see here, solubility of water increase by temperature. Solubility, this is solubility axis and the y, and here temperature is the axis x. So we see here the solubility of water increase by temperature for one gas. What do we mean by dew point depression? Dew point, what is a dew point? Dew point is the temperature at which the first the water vapor will start to condense. So here, what is a dew point depression? As we see here, we have raw gas, we have pressure, temperature, gas content, water content. All this figure is just figure. And dehydration unit, here after dehydration unit, we have to reduce the dew point. How to reduce the dew point? We have to remove as much as water from the gas. How we remove it? By dehydration unit or by cooling. Or here we are talking about dehydration unit using glycol. So here free water removed around 23 pound water per standard per 1 million standard cubic feet. So here in the sales gas, what happened here? We have the pressure, it's still same. We have temperature. What happens? The temperature decreased, as we said. The mean here reduced temperature, and water content is reduced by from 30 pound to 7 pound. This is what we called water dew point depression. So dew point depression is around 40° Fahrenheit. Hydrate form. How the hydrate is formed? It's formed with through the reaction between water and these gases. So hydrate form when free water combines with the following gases: butane, carbon dioxide, ethane, hydrogen sulfide, methane, nitrogen, and propane. So what we are talking about the hydrate. What are the hydrate? Hydrate are solid components that form as crystals and resemble snow in the appearance. They similar to ice. They are created by reaction with natural gas with water. Hydrate have specific gravity about 0.98 and will be usually float in the water and sink in the hydrocarbon liquid because it's mixed from hydrocarbon and water. So it will be in average between both of them, not heavier than water and heavier than gases or hydrocarbon. Water is always necessary for hydrate formation as well as some turbulence in the flowing gas stream. So we have structure, different structure. Hydrate is a water lattice with a series of open spaces. As we see here, this structure 1, structure 2, structure H. So here for methane, ethane, carbon dioxide with water, this is the shape of structure of hydrate structure. While we have here a little bit heavier propane isobutane, we have this shape of the hydrate structure, and we have here methane. This is the shape of structure of the hydrate. So when the natural gas component, see natural gas different methane, ethane, propane, isobutane, H2S, CO2, and nitrogen enter the water lattice and occupy the vacant lattice positions, causing the water to solidify at temperature. Even this temperature is higher than freezing point of water. As we see, this is here hydrate. This is hydrate formed. As we see, it's similar to not ice. It's similar to a stone because it is make a big problem and blockage cause the blockage in the pipeline. And I think no compressor can overcome this this blockage in the pipeline. The only methods to solve or to overcome this problem only just to wait until the temperature increases, then we can resume our system. What are the factors promoting hydrate? What are factors promoting hydrate formation? We have free water, high pressure, low temperature. So these three conditions are primary condition for hydrate to be formed. If we don't have any one of these conditions, so hydrate will not form. So, but the most important is that we have free water. If we don't have free water, that means hydrate will not form. Free water, even the gas having some water vapor, and that vapor doesn't condense, no possibility to form to be formed. Also, we have some secondary condition, high velocity physical sites where the crystals might form, such as pipe elbows, orifice, and line scale, turbulence in the gas stream. How can we prevent it? By heating the cold. As an hydrate formation can be prevented by heating the cold and processed gas stream, chemical inhibitor injection like glycol or methanol. Injection of chemical should be upstream of, as we said here, some condition where we have it's more suitable for formation, hydrate formation. So we have to inject the chemical upstream of choke valve, upstream of heat exchanger, upstream of what we call the orifice plate. So to prevent hydrate formation. So now glycol dehydration. We start our glycol dehydration here. The glycol dehydration, the natural is, as we said before, that natural gas is fully saturated with water vapor, and when produced from the well, the water vapor content of natural depends on composition of the gas, temperature, and pressure. To meet the required specification to sell and transport gas in the pipeline, the vapor water has to be removed through the dehydration process. One of the most common methods for removing the water from the produced gas is glycol dehydration, or we call it TIG, triethylene glycol. Here, if the gas having H2S and CO2, what is the effect of H2S in the gas? So they increase saturation water content in the natural gas. They are readily dissolved in the glycol. If these both gas are we didn't remove during the sweetening system, and we proceed this gas for dehydration, this gas will reducing the pH in the system, and this will lead to corrosion in the facility. CO2 and H2S react with MIA and acid neutralizer, monoethanol, and for dehydration, we have this type of dehydration of glycol. We have 4 types of glycol. and the triethylene glycol is the best one to be used for as continuous treatment. Triethylene glycol take for we call it continuous dehydration system. Why? And also here we have the physical property of all glycols, as we said here, all different type formula and molecular weight, boiling points. So we all these very important to operation engineer or in the site to know the specific property of the glycol which is dealing with it to avoid any problem such as decompositions or how to what is the temperature has to be controlled to keep eye on that to avoid losses or evaporation of that glycol. So triethylene glycol is the most used glycol for dehydration of natural gas because why it is easily regenerated to higher purity, to higher degree of purity. Vapor losses are lower, operating costs are lower. So uh, for glycol dehydration unit consists of two sections, or we can divide it in two sections. One section we call it gas dehydration and glycol regeneration. So for the first part, what is the main component in this part of gas dehydration? Of course, we have inlet scrubber, contactor, and inlet cooler. So here in the contactor is the main equipment in the glycol dehydration, where all the exchange between the water vapor between the gas and the glycol it will happen here. So in the contactor, in the according to the type of the contactor. Also, we have glycol regeneration system. Glycol regeneration system, we have heat exchangers, we have reboilers, the main facility also the reboiler to regenerate the glycol again by heating it to the uh, temperature below the uh, decomposition temperature of the glycol. So we can confirm that all water is released and evaporated from the glycol. As we see here, this is simplified process flow scheme for triethylene glycol system. As we said, this system is continuous system. So the glycol is used we can say in a closed circle. So the glycol will contact in the contactor here. This is the contactor. The glycol coming from generation system from the reboiler through the pumps. Here, this is a glycol circulation pump. It will go to here in the contactor. This glycol, we call it lean glycol. That means doesn't have water, and purity of this glycol is should be around 99.6 to give us the required specification of a dew point for in the exported gas. So here, wet gas is coming here. This is the inlet. So we have cooler to cool the gas. Then we have here the what we call here the inlet separator. So after cooling, so to remove any separated liquid and reduce the load on the contactor and the glycol. So gas is coming from here. This type of contactor is we call it structure backing, not tree. So gas will go through the backing, and liquid lean glycol will flow downward. So here will having contact between both between the gas and the glycol. So the glycol will absorb the water from the gas giving us the required content of vapor water in the gas exported gas. So here the lean glycol here, what will happen here, the lean glycol. So as I told, this is a closed circulation. We need to regenerate this glycol by taking all the water, which this lean glycol take it from gas and became as rich glycol. So here we have reflux. This reflux also we'll talk about it in details in our course. We call it initial heating for the glycol as first step of heating, then of a glycol. Then glycol will go to flash tank here so any dissolved gases still in the glycol will be released here. Then glycol will continue through uh, glycol will continue through the flash tank. From flash tank to filter, we have different types of filter. We have uh, particles filter and we have carbon activated filter. Then go through heat exchanger. This heat exchanger also the second stage of heating, because this lean glycol is coming from surge drum. Then this one, the rich glycol flow to the still column. From still column will flow down to the reboiler. From the reboiler overflow here. This reboiler is fire tube. Called the fire tube heater. The fire tube should most of time emerged by glycol to avoid the problem and hot spotting on the fire tube. So glycol will overflow from here to through stripping column to the surge drum. So here, as we said here, this is surge drum. Sometimes we add to improve the purity of the glycol, we add stripping gas in the stripping column or in the reboiler. So stripping gas will catch any very fine water droplet. Here also, then the glycol, which became as rich lean glycol, again will be sent to the system through the pump, glycol circulation pump. So as we say, this is a closed circle or closed loop for dehydration, continuous dehydration system for the gas. As operation team, they have to keep eye on this operating parameter or continuously operating. Mainly, we have to observe temperature in the reboiler. Should not increase or should increase more than the set point. The set point mostly it will be around 198, between 198 or between 195 to 198 Celsius centigrade, because temperature 204 Celsius is maximum that will cause decomposition of glycol, and once we reach this temperature, the glycol will lose its properties to absorb water. Also here, what is important here also, filters. We have to keep monitoring on the differential pressure across the filters. So any differential pressure across this filter, we have to clean this cartridge or replace this cartridge. One of the important things also here in the contactor, here this point here, when the gas is leaving gas is not shown. It's not shown here. And gas, dry gas. The dry gas is leaving the contactor. Should go through a heat exchanger. The heat exchanger with uh, to get some heat from the glycol, and the glycol here. This is not shown in the this sketch. So we, as I told, we have here the drying gas should heat should go through or flow through heat exchanger between the lean glycol and dry gas. So we have to maintain some certain pressure that glycol should be around 6 to 7 or 5 to 8 Celsius higher than the gas coming to the contactor. Here, what is most important, also another thing is important here, the level of glycol. Here also, we have to observe condensate, if more condensate coming with the gas or not. We have to take care about it. The level of condensate, this is valve, level control valve will control the level in the contactor. Also, we have to keep a certain level in the contactor to avoid any gas coming to the reboiler system. Here, this is point we can add glycol adding. Here we have we add fresh glycol to the surge drum. The level of surge drum, sometimes we should keep it around 60%, 70% all time. Here also this reflux, as I told, it's give us good functions by cooling the vapor which is releasing here. Here this is reboiler, and we have here, as we said, still column. So we have here some vapor coming through the still coming to the vent. So when the vapor go through this around this reflux coil, it will lose its temperature, and it will we call it reflux. Why it's reflux? Because it causes some vapor to condense again and flow down, settle down to the reboiler. So if we have any losses from the glycol through this point, it will condense again, and fill down to the reboiler. So this is description already. Mentioned contactor. As we see, glycol type, we have two types of glycol contactor. So we have tray towers, as we see here. We have tray tower, and we have the other type of contactor are packet tower. Packet tower also we have two types. Either could be structure backing, as we see here, structure backing. All this structure will become and install inside the tower, while we have here random backing. Here this is flow through, as we see, this is bubble cap tray. The most efficient way of mixing between gas and glycol is bubble cap tray. We have different trays. We have either sieve tray or perforated trays, but the most efficient are the bubble cap tray. So here, what we have here, as we said, the gas is coming from the bottom through the bubble cap. So it will come in contact in the glycol. This glycol here, we have seal level of the glycol. This seal level is maintained by the weir. Here, this is the weir from the tray. So this weir here maintain a certain level, of glycol in the tray deck. So when the gas comes through the bubble, it will come in contact with the glycol, and the glycol will observe the moisture of the gas. Here, we have downcomer. So glycol will come through the downcomer from one tree to the second tree. One of the most problem happen here of sometimes the glycol or the gas doesn't go through the bubble cap tray. Sometimes it go through here through the uh, downcomer. So we have to this problem also we'll discuss it during our uh, course. Also the operating problem we discuss in our course about foaming, also vapor losses, glycol losses, all these things. So we have, as we said here, different types backing structure. This is backing structure. Here we have random structure. Random structure, just we bring this type of backing and put it inside randomly without any ordering. Just dump inside the tower. Why? As this is the bubble cap tray, which is the best one for gas dehydration, or either here or either in the distillation tower also. But it's a little bit expensive. It's the most expensive than other type of backing or other type of trays. So the tray here, as you tell, you have this is tray. This is inside this is the tray. As you said, we have liquid. We have liquid here, and this seal of liquid is maintained by the edge here of the tray or weir. So we have to keep a continuous level of contact of glycol in the tray deck. If we lost this one of the lost if we lost this seal, what will happen? That means glycol will go through this cap. If it's different type of tray, sieve tray, if we lost the level, so or we have very low flow gas, what will happen? So it will this cause a problem called webbing. So glycol will flow through the tray to the below tray. So it will affect the operation of the glycol unit. Here we have structure backing. This is structure backing. This random backing. Function of reboiler and reflux condenser. This is, as we said, still column. Here, reflux drum, and here we have the reboiler and the reboiler direct fire heater. So here we have stripping column, and we have here the surge drum. This is here. So reflux improves the separation between water and glycol. The condenser also minimizes glycol losses from regenerator. The remaining water vapor leaves the condenser and is vented to the atmosphere. The temperature of is around 98.9 Celsius. Reboiler, the function of the rich glycol enters the top of the still column at the atmospheric pressure. So we have the pressure in the reboiler is at atmospheric pressure. The glycol is heated to its boiling point. The glycol releases all the absorbed water. The heat is usually supplied through the fire tube in the reboiler in which the natural gas is burned. The fire tube always must be submerged in the glycol by having the glycol flowing through the reboiler over a weir which is higher than the top of the fire tube. As we the weir here, this weir should maintain a level of glycol inside the fire tube higher than the fire tube. Because in some cases, for malfunction of the reboiler, the liquid of glycol or the level of glycol became, for any reason, become here less than this weir, and some of the fire tube is exposed. We don't have to the gases here, so, and we don't have what we call glycol to absorb the heat. So here we have dangerous situations that fire tube could be if the temperature, if this situation continue for a long time, could be ruptured or deform, and hot spotting will form. Certainly, hot spot will be formed on this wall of the fire tube. As we said, the temperature uh, at 204, the maximum temperature of the reboiler. So we should not go higher because glycol will be decomposed. Uh, one recommended is one between 195 to 198. That will give us around 97 purity. If we need to increase the purity, we have to add stripping gas. Stripping gas, we can get increase the purity of glycol to 99.6, because the purity is very important for glycol. If the as much as we have higher impurities, then more absorption in the contactor will happen, and we will get the required specification, and we reduce the dew point of the exported gas. Fire tube, here we have stripping column, stripping column between the here stripping column between the. This is we have different different constructions. Either it could be like this and could be aside from here to here in between it. So we have different constructions, and we have stripping gas flowing through the stripping column, and stripping gas also flowing in the reboiler. So any still remaining water droplet, the stripping gas can catch, and this gas will go to atmosphere. Glycol pump circulation. This is the pump. Circulation pump. This is the pump is usually a reciprocating pump. Main problem with this pump is leaks through the plungers, and also in the winter when the glycol became little more viscous. Sticking valves, because as we said, this is a reciprocating pump, so we have internal valves and check valves. So this the ball of these check valves will be get sticky, and operation of the pump will not operate as required to circulate the required flow rate. Also, we have backing nuts. Sometimes leakage happened about the backing, and if this backing is more tighted, too much tighted, it's the rod maybe get scored. Strainer, always in the suction strainer, we have to install the strainer in the suction line. So any particles we have to remove from the glycol, because any particle is could be the reason of foaming in the contactor. Heat exchanger, just we have heat exchanger, two heat exchanger, or here two heat exchanger in the system we have, and we have this also gas glycol heat exchanger. All heat exchanger is to exchange the heat between the glycol and the gas, and they reduce the load on the reboiler. So we heat the glycol first time here in the reflux, then heat exchanger before entering it to the reboiler. Filter, this is kind of filters. As we said, we have two different type of filters: particles filters and carbon filters. Surge drum. The surge drum is usually located below the reboiler. The level of the glycol in the surge drum should be about 2/3 of the level. If the level is lower than the normal, this might be the first indication of trouble. So if we notice that the good operator, he has to notice and keep monitoring the level in the surge vessel. If he noticed that the level is became less than normal, because we have acceptable losses of glycol. If this during one week we have more losses, that we have problem. So that means high losses, losses of vapor leaks, could be leaks in the boiler, uh, could be hold up in the vessels and leak in the piping. Flash tank, as I told, its flash tank is almost atmospheric pressure. Could be 1 bar, could be more than 50, up to 50 bars. The glycol first, as we see from drawing and here drawing, the first equipment here, for the glycol, for the rich glycol is to go through flash tank. After little bit cooling, after a little bit increase heating, after getting some heat from the reflux coil here, the rich glycol is flow to the flash tank, where any dissolved gas in the glycol will be released and avoid any gases going through the filter to the reboiler. For circulation rate, as we said, circulation rate should be between 2 to 6 gallon of triethylene glycol per pound of water. What will happen if we have over circulation? So here, heat load in the regenerator. So that means over circulation means more glycol circulated in the system. That means more load will be in the reboiler to regenerate and regenerate all this glycol. Then return to conductor is higher temperature because less efficient at heat transfer. More hydrocarbons are absorbed, especially compounds such as benzene, toluene. If these compounds are present in the gas, additional acid gas is absorbed if sour gas is being dehydrated. Glycol purity, what will happen here as what uh, what happens that affects the purity of glycol? We have oxidation, thermal decompositions, pH control. The pH should be continuous. We have to maintain it between 6.5 to 8 by neutralizing the acidic component by borax or soda ash or other alkaline chemical. We have other problem also, salt contamination, hydrocarbon contamination, sludge forming. All these problems will be explained during the course in details. So I take here one example, foaming. What will happen here in the foaming? What is the foaming? Foaming is the most likely to be problem in the bubble cap tray. Bubble cap is so most in the bubble cap tray, the foaming have more chance to be formed. Foaming increase glycolysis and reduce capacity of the system. As we say here, it takes more capacity of the vessel. Foaming causes glycol to carry over to the top of contactor with the sale gas if stable foam build up on the tray. So if we have stable foaming, foaming will flow with the gas through the contactor, the top of the contactor, the sale. Foaming causes also poor contact. If we have here foaming, so we have poor contact between gas and glycol, and so poor efficiency and of separations or removal of water of the glycol of the gas. So some foam promoters, what are the main reasons that foam will happen? Hydrocarbon liquids. If we have any traces of hydrocarbons, any corrosion inhibitor, salts, finally suspended solid, excessive turbulence, and high vapor to liquid contacting velocity will usually cause the glycol to uh, form. This condition can be caused by deposit on the tray and gas rate greater than design. What is the remedy action? First of all, as we said, we have to we have to consider all these causes of the foaming. So we have our troubleshooting. We will focus on the reason. So first of all, we don't need any impurity to go through the glycol. So here, cleaning by filter system with filter system, using anti-foam agents. This anti-foam should not be used as continuously. Only we have temporary usage until the problem is solved, because anti-foam is not a solution for a continuous solution. Most because deactivated within a few hours under the high pressure and temperature condition, and their effectiveness can be dissipated by the heat of the glycol solution. Here, if we don't have problem of foaming, if we add anti-foam, this anti-foam can act as foam promoter, while anti-foam should be injected or added after foaming problems. Glycolysis. Also, glycolysis can be very serious and costly operation. As we said, this glycol is a very expensive material, chemical, and so we accept minimum rate of leakage or losses. More than that rate, that means we have to investigate where is this losses. Losses can occur by vaporization, entrainment, or mechanical leaks. Total glycolysis from if we have properly designed and maintained dehydration unit, are typically between 20 to 60 liters per million standard cubic meter. This is described here here. If we have some problem, we didn't meet the dew point of the gas. What is the reason? Why we didn't meet the reason? Here, high water dew point. This could be different. Many reasons could affect this reason. Gas inlet temperature higher than design. Gas inlet pressure lower than the design, combined with a normal or higher temperature. Insufficient circulation rate. If we don't have enough circulation rate of the glycol, that will keep some water in the gas due to low pump rate, low glycol level in the surge drum, check valves on the suction and discharge of the pump not holding, suction strainer blockade, or foaming. Here, insufficient glycol regeneration also, too low boiler temperature, higher water inlet separator carrying water into the absorber, leak in the rich lean glycol exchanger, insufficient stripping gas, foul stripping column backing. Here we have normal operation. What we have to check, as we said, we have to check all the operating parameter of the unit, the glycol level, pressure, temperature of the systems. Where if you have any leaks, we have to in the system, if the pump running quietly without noise, without any leak, plunger leak. So we have daily log sheet that operator we have to maintain taking or reading of this unit. So to confirm that smooth operation of the dehydration unit and without any losses. I will stop here now.